Hi, and welcome to the new section Optimizing Python Code using Cython. The first topic in this section is Introduction to Cython. So, going forward, we will be covering the following topics: what is the Cython module, the Cython workflow, and how does Cython help in optimizing Python code. So, let's go ahead with the first topic: what is Cython? So, as you might have guessed, Cython is basically C code with Python. The idea behind Cython is to use C data types, functions, modules, etc. within the Python code. So basically, Cython translates your code to optimized version of C code, and this optimized C code can be used with your existing Python code. Cython is a superset of Python. What this means is that all Python code can be considered as valid Cython code except few exceptional cases. So before we move ahead on how Cython works, let's understand the Cython workflow. So first, you translate the code written in Python to Cython code. So basically, you try to identify the code that you want to optimize and you translate it to Cython. Then you compile the Cython code and bundle it to Python extensions. Once these steps are done, you use the bundled Python extension in your existing Python code. Now let's try to understand how does Cython help in optimizing the Python code. So before we move into how Cython helps, let us first understand why Python is slow. So the first thing is that the Python interpreter by default is very slow. This is mainly because of the fact that Python is a dynamically typed language. So what this means is that suppose a variable x is declared as integer in the beginning of the program. Towards the end of the program or throughout the execution of a program, the data type of x may change from list to dictionary to tuple to set or anything. Since Python is an interpreted language, so it tries to basically execute the program line by line. So in each line, whenever it encounters the variable x, it needs to dynamically check the data type of x. This requires the Python interpreter to execute various commands at runtime to pinpoint the final data type of x. Now, this can be quite a time consuming process. So how Cython helps us is that it combines the following two properties of C to enhance the execution time of Python. First is the static type nature of C. What this means is that unlike Python, variables declared with a certain data type in C remain same throughout, even at runtime. So if a variable x is declared as integer at the beginning of the program, it will remain as integer throughout the execution, even at runtime. So the C compiler does not need to check the data type again and again, and it does not need to run complex instructions to pinpoint the data type. Also, Cython brings in the compiled nature of C. What this means is that once the code is compiled, it does not need to be like compiled again and again to check for dynamic changes in the data type. So you basically bundle that compiled code in your existing Python code and it does not need to be checked again. So this saves us a lot of time. So that's it for this lecture. Let's do a quick recap of what we have learned. The Cython module works in conjunction with the Python. It allows us to use C data types, functions, etc. inside existing Python code. It makes use of C's static type checking nature and compiled nature to speed up existing Python code. So that's it for this lecture.